All right, we have 3.3 factor theorem. The factor theorem is very similar to the remainder theorem, except the remainder is 0. So the factor theorem just states that if you plug a value in and you get a remainder of 0, then something is a factor. Which makes sense, because we know that when we get an answer of 0, that's an X-intercept, correct? Because it's just y equals 0 and whatever the heck the x value is. So we found an X-intercept. So we know that we plug in the x value into the polynomial and we get a y value out, correct? So when we plug in an x value and we get a y value of 0, we get an X-intercept. Therefore, backwards from that is the factor. So an example, in grade 11, when you were asked to factor, you'd factor something. You'd get like x plus 2, x plus 4, let's say, right? When we solved that down for the X-intercepts, we get x equals -2 and -4, right? We solved them down. Yeah? Well, remainder theorem can determine whether something is an X-intercept or not, can it not? You plug in the x value and see if you get a y of 0, then it's an X-intercept. So if we know if something is an X-intercept, we can actually work our way backwards now and get the factor. Can we not? Instead of going from factor to X-intercept, we can go from X-intercept to factor. So this one says, verify that x plus 2 is a factor. Well, we can't fill x plus 2 in there, but we can fill the root in. We can fill the x value of it. What would the x value be? What did we fill in before? X equals what? -2. So let's plug that in. So we're going to find f of -2. And we get -2 cubed plus 5 times -2 squared plus 2 times -2 minus 8. So we get f of -2 equals -8 plus -2 squared is +4 plus 5 is, or times 5, sorry, is 20. And then 2 times -2 is -4 minus 8. F of -2 equals -8 and -8 and -4, which is -20 plus 20. So we get f of -2 equals 0. And do you see how many steps I did? If this is a written response on the diploma and you made a mistake in the very first part and you only gave the last answer and it was wrong, so you only stated the first step in the last answer and you got it wrong, could you get any part marks really? No. But if you show your work along the way and you make a mistake maybe right before the end, could that deserve probably more part marks than if you didn't show your work? Yeah. So show your work as much as possible. So what the heck does f of -2 equals 0 mean? What else does that represent? Other than the remainder is 0. And -2. So we know that the remainder is 0. We know that. That's what this tells us too, right? The remainder. But we also know that we have an X-intercept at -2, 0. So what was the factor then? If it was x equals 2. X equals -2. What was the factor then? So it was x equals -2. How do I move it back? Because to get the factor, you have to get it back equal to 0. So you'd add 2. So it would be x plus 2 equals 0. So even though that this is the X-intercept, the factor is x plus 2. So how do you verify that something is a factor? You show the remainder is 0. Because if the remainder is 0, then that's an X-intercept, right? And the factor is the reverse of it. I want you guys to use remainder theorem. Show me that x minus 2 is a factor. Is a factor should just instantly, you should think remainder 0. That's how you show it. So we're going to find f of what? 2, right? Our factor is x minus 2. We're going to use f of 2. So we're going to get 2 cubed minus 6 times 2 squared plus 3 times 2 plus 10. So we're going to get 8 minus 24 plus 6 plus 10, which is 0. Okay? Now, in order to factor anything that is cubic or degree 4 or degree 5, we have to get a factor first. So when it was degree 1 and we had to just solve it, we solved it easily. When it was degree 2, when it was degree 2 last year, you would either factor it or you use quadratic formula to solve, right? When it's degree 3, you have to find a factor first and use synthetic division. So in order to find out if something is a factor, we need a potential 0. Okay, until now, they've given you a possible factor to try, correct? And then you plugged in the root and seen if it got you an X-intercept. We agree? Right now, it just asks us to factor that. So we have to look for possible X-intercepts. So you could put in possible numbers for life. That would suck. Or the best method to figure out your possible zeros, or possible X-intercepts, are the factors of the constant. That took a long time to get there. All right, so plus or minus 1, or plus or minus 2, or plus or minus 3, or plus or minus 6, which sounds terrible that you'd have to try all of those, but that's 8 rather than a world of numbers that you could just possibly punch in. So it's based on the constant at the back. It's always based on the constant number, and you take the factors of it to check. Now, will all of them work? No. But you have at least 8 to try. Now, that could take you 8 remainder theorems, which could suck. You would only have to do this if you didn't have a calculator, right? Your calculator can find an X-intercept very quickly for you, can it not? So that's what we're going to do. So plug this into your y equals. Plug that into your y equals and go to a table of values and take off the smallest X-intercept. And why would I take an X-intercept? Because the X-intercept is what's going to give me a remainder of 0, correct? Because the X-intercept gets me a y of 0, which is a remainder. What's your lowest one? Type it into your calculator and look in your table of values. What's your lowest X-intercept? -3? Okay. So we are going to go x equals -3. Now, think about this. What are the possible number of X-intercepts on a linear function when there's just a line? How many X-intercepts? 1. There will always be 1 and max 1, right? A quadratic could be completely above or completely below, so there could be 0. There could be 1 if it just touched in one spot, but at maximum, how many X-intercepts does a quadratic have? 2. At maximum, a quadratic has 2 X-intercepts. So a cubic would have at maximum how many? 3. Does it have to have 3? No. If you press graph, you could see what it looks like. It's usually an S shape. So it could look like this. So it can have 1 X-intercept, or it could have 2, which this is touching, or it could have 3. Could it ever have none? Arrows in opposite directions. Could it ever have none? No, it could never be completely above or completely below. All right, so we picked the smallest one, x equals -3. There's 2 other ones on your table of values. So you could just work those 3 back quickly and give me the 3 factors and be done. However, is that algebraically at all? No. So you're going to learn the algebraic approach. Now, it looks way more overwhelming than it is. You're going to draw yourself an L. Don't draw it over here. I'm just showing you. You're going to draw an L, and you're going to have numbers up here and numbers down here. So make sure you draw your L long enough so that you have space to write 2 numbers in it. So I'm going to draw it like this. So we are going to use synthetic division to break these factors down. Because the only thing we know how to factor maximum right now is x squared. We agree? And currently we have an x cubed. So what we have to do is we have to make sure we can count down. So we have 3, 2, 1, 0. If we couldn't count down, we'd put a 0 as a placeholder. So for example, if we had x cubed plus 3x minus 6, we would write x cubed plus 0x squared plus 3x minus 6. And we'd put a 0 in for the x squared one. Okay? So if you're missing one, you have to put a 0 in. You have to be able to count down. Do you understand what I'm saying? Okay. So here we have 3, 2, 1, 0. In the synthetic division sign, what we're going to put is just the coefficients, not the variables. So we're going to put a 1 because that's what's in front of the x cubed. We're going to put a 2 because that's what's in front of the x squared. We're going to put a negative 5 and then a negative 6. Okay. The next part looks overwhelming, but it's not. All we're really doing is multiplying, then adding, multiplying, then adding, multiplying, then adding, multiplying, then adding till we're done. Okay? We're going to literally drop a number down, then multiply, add, multiply, add, multiply, add, multiply, add till we're done. Okay? Looks more overwhelming than it is. So, drop the 1. That's the only time I'm not going to just multiply, add, multiply, add, multiply, add. Okay? So I drop the 1 down. Now I have 2 numbers out here. What do you think I'm going to do with them? What did I say we do? Multiply, then add. Multiply, then add. So we're going to multiply first. So we're going to multiply these 2. Negative 3 times 1 is? Negative 3. It's going to come up here. We finished multiplying. So what do you think we're going to do now? Add. 2 plus negative 3 is negative 1. We finished adding. So what do you think we're going to do? Multiply. 3 times negative, or negative 3 times negative 1? Positive 3. Now we finished multiplying. So what do you think we're going to do? Add. Negative 5 plus 3? Negative 2. And then we are going to multiply. Negative 3 and negative 2 is 6. And then we get a 0. And we box this. This is the remainder. So if it's not a 0, you did not use an X-intercept. Right? Because this is my X and that's my Y. We agree? My remainder is just my Y value. So if you didn't get a 0, you didn't get an X-intercept. You picked something else. Often you pick the Y-intercept or you messed up in your synthetic division. Okay. So we have one factor. If this is x minus 3, x equals negative 3, sorry, what's my factor? X what 3? X plus 3. It's just working back, right? If I had x plus 3, it was x equals negative 3. So if I have x equals negative 3, it's just x plus 3. Yeah? The table of values on your calculator is just an X-intercept. Yeah. And if we didn't have our calculators, we would literally have to plug these ones in each till we, in remainder theorem, till we got a 0 as our remainder. But because we have our calculators, we can just pull a value off. If they want to prove to you, if they wanted you to prove to them why it was, like algebraically, you would have to take this negative 3, plug it into remainder theorem to show it was 0. But you are proving right here that it is. Yeah. So we have one factor. We have x plus 3. We also have another factor, this. So if we pulled an x plus 3 factor out, we've pulled out one x. We had an x cubed. So now we're actually at an x squared. So this is a 1 x squared. And then we just work our way down. Minus 1 x minus 2. You took an x out of x cubed, so now you have x squared, x number. Yeah. Because you just took an x out of x cubed. This is one factor already taken out. So this one has to be one less than the x cubed. It's always one less than whatever the heck this is up here, because you took one out already. Now are we fully factored? No, we have to factor this. So I'm going to do that right here. X squared minus 1x minus 2. So I say what times what gets me 1 times negative 2, which is negative 2. And what plus what equals my middle term, which is negative 1. What multiplies to give me negative 2 and adds to give me negative 1? Negative 2 and positive 1. We can go right to x's in brackets because there's a plus 1 in front. If there was anything but a plus 1, you would have to do decomposition. But we can go right to brackets because there's a plus 1. So we get x minus 2, x plus 1. And now this can be replaced with x minus 2, x plus 1. And then this is x plus 3. And we could say f of x equals this. So this would be the complete factored form of it. So how many x-intercepts does this graph have? 3. X equals negative 3, x equals positive 2, and x equals negative 1. But I didn't ask for x-intercepts, I asked you to factor, right? How could we check these now? Plug this into your y1. You should have it there already. Do you have it there? Your original should be there because that's how you got your x-intercept in the first place. And this should go into your y2. These should be the same thing, should they not? If you FOILed this out, should you not get the original? Yes. Would that take quite some time? Yes. So why do that? Why not type that one into y1 and type this one into y2? It should be the same what? It should be the same graph. Now what happens is people will type them in and they'll get one graph and they'll be like, boom, they must be the same graph. I can only see one. But what actually happens is they have one graph down here and one graph floating in the air up here, but they can't actually see it up here, so they just assume that they're the same graph. So the only way that you can actually see that they're the same graph, if you don't have one that changes the colors, if you have one that's different colors, great. It draws one color over the next color. You know they're the same. If you have one that is not that way, go to your y2 and arrow all the way to the left where there's a slash. So go to your y2 and arrow all the way to the left where there's a slash and hit enter once. It makes the line thicker, right? So in y2, you arrow all the way over to the left where there's a slash and you hit enter once and it makes a thicker line there, doesn't it? So now press graph and it'll draw your y1 like normal and your y2 will actually be drawn thicker over your y1 so you actually know that they're both being drawn rather than you hope that they're both being drawn. So when you press graph, it'll draw the first one as a thin one and the second one as a thick one directly over it. And then you know you're right. Okay? Yes? Yes. So that's the other thing. When I teach this, it annoys me because what happens is you'll press 800 different options to see what it does. There's dashed lines, there's a shaded and another shaded. There's also one that looks like keys. They're of no help to you. Stop it. Stop it now. We're going to move on. Okay. Next page. So this one, what are my possible zeros? What are my possible x-intercepts if I have to actually prove it? Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Those are my possible integral zeros. So type the original one into your calculator and see if you can find an x-intercept. So you're typing it into your y equals, and you're looking in your table of values for an x-intercept. The constant at the back. It's just the factors of 10. Numbers that multiply to give you 10. So this one would be 1, 2, 3, and 6. This one would be 1, 2, 5, and 10. This one would be 1, 3, 5, and 15. It's just the factors of what multiplies to give you this back number. Does anyone have one? X-intercept? X equals what? Did anyone get one? 5? Now, what if I pick one of the other two? What's going to happen? Is there another one? Let's go back here. Let's go back to this one. This one's a good one. So say instead if I hadn't picked x equals negative 3. Paying attention, please, so I don't lose you. I picked negative 3 because I told you all to pick negative 3. But you could have picked 2 or negative 1 in your calculator, correct? Yes? So say I picked negative 1 and I put it in here. What would this factor down to? Now, would it be the exact same bottom? No. it would be the factors that make up the other two, x plus 3, x minus 2. Or had I plugged in 2 here instead, this would be the factors that make up the other two. So it doesn't matter which one you pick. The end result will get the other two factors that you didn't pick. Okay? So let's go back here. So 5 is the one that works, so we're going to pick it. Now I'm going to go 1, negative 27, and 10. I didn't write it for a reason. What do I need? What am I missing? Yes. For which one? X squared. I need a 0x squared in here. So I need 1, 0, negative 27, and 10. The people who forget the 0 sometimes think that they picked the wrong x-intercept off of the calculator. You didn't pick the wrong x-intercept. It just didn't work out because you forgot the 0 placeholder, right? Because remember, if you pick a proper x-intercept, you should get a remainder of 0. So I dropped the 1. 5 times 1 is 5. I multiply. Now I add. 0 plus 5 is 5. I added, so now I multiply. 5 times 5 is 25, and now I add. Negative 27 plus 25 is negative 2, and now I multiply. 5 times negative 2 is negative 10, and then I add, and I get a 0, which makes me happy, because I need a 0. We agree? X equals 5. What's the factor? X what 5? X minus 5. So I know I have a factor at x minus 5. And my other factor is this. 1 less. So if this is x cubed, this is going to be 1x squared plus 5x minus 2. Can I factor that? What multiplies to give me negative 2 and adds to give me 5? No, there's nothing that can factor. So if I say factor and you can't factor it, you're done. And this is your answer. So on the test, what they'll ask for is a linear factor or quadratic factors. This is a linear factor, x minus 5, because if I drew it on a calculator, if I went y equals x minus 5, what would it draw? A line. It's linear, right? It's degree 1. This is a what factor? Quadratic factor, because it would make a parabola if I drew it, which means it's a quadratic. They're not crazy like actual definitions. Linear factor is a linear, a line, that's a factor. And a quadratic factor is a quadratic, that's a factor. Quadratic factor. They actually did good definitions here. Okay? Now, these all had 1s as their leading. So if they start off with a 1, then you can do product sum, because you're going to end up with a 1 down here, correct? This one I couldn't factor, so it was even better. But if I have a 2 or something as my leading coefficient, it's going to end up making me do decomp. So type this one into your calculator. This one here, my possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Which one works? Which x-intercept? Which x-intercept works? First person to say one wins. Yeah. 3. So we're going to use x equals 3 with the factor then would be x minus 3. Can we count down? 3, 2, 1, 0. Yeah, so we can just put in our coefficients. 2, negative 1, negative 13, negative 6. And then we're dropping down the 2. And now we multiply. 3 times 2 is 6. And then we add. Negative 1 and 6 is 5. And then we multiply. 3 times 5 is 15. And then we add. Negative 13 and 15 is 2. And then we multiply. 3 times 2 is 6. And then we're happy because we're getting a 0. Now our one factor is x minus 3. And our other factor is 1 less. So if this is x cubed, this is going to be 2x squared plus 5x plus 2. Yeah. Went to the table of values and found an x-intercept of 3. No, it can be any of them. No. In this case, there's 2 that you could have picked from there. Absolutely. It's just that when you do decomp, then you'd get that x minus 3 as one of the factors. As long as you pick an x-intercept, nope, doesn't matter. So off to the side, then we're going to factor it. We have 2x squared plus 5x plus 2. The first part is not the problem. And honestly, if you can't do decomp, you need to come in and admit you can't do decomp. Okay, and be like, Mrs. Lepp, help me, I still can't do decomp. Completely fine with that. Better than finding out you can't on your test, right? That would be horrible. Okay, so it's the same as before. What times what gets me first times last? So 4. What plus what gets me middle? 5. Nothing has changed between that and product sum, right? We still find the same numbers that way. What are our numbers? 4 and 1, we agree? In grade 10, you learned grouping. Grouping was this weird factoring thing where you had 4 factors, and then you would group 2 and group 2, and then you solve them all out and all that stuff, and you're like, why do we have to learn this? We've never used it. You actually used it in decomp. That's the reason why you learned grouping, okay? Now, what is decomp? Decomp is some steps that form to give you 2 factors. We agree? But you don't need to memorize the steps. Just understand what you're doing. Then you aren't memorizing, okay? So what we used to do is we memorized keep the first, keep the last, replace the middle. But why are you replacing the middle? Well, we have 5x, correct? Here we have 4 and 1. What's 4x plus 1x? 5x, is it not? So that's why you're only replacing the middle, because you're taking the 5x, you're hucking it over your shoulder, and you're replacing it with 4x plus 1x. Because what's 4x plus 1x? 5x, right? So we're keeping the first term. This equals 2x squared. We're replacing the 5x with plus 4x plus 1x. Could I write it as 1x plus 4x? Does that matter? Is that still 5x? 1x plus 4x? Absolutely. Doesn't matter the order. And then plus 2 at the back. We agree? So we literally just replaced the 5x with 4x plus 1x. Yeah. No, they'll always work. Sometimes it's just easier if you have them in the other way. So if I go 4x plus 1x or I go 1x plus 4x, it does not matter. It just might be easier if you have them in a different direction. But it'll still get you the 2 factors. It'll just get them in opposite order. So the order of them makes it easier, but it's not necessary to have to be in that order. Yep. Okay. Then grade 10 grouping. We group the front 2. We group the back 2. Now you can see in those brackets that we could take something out of both of them, right? What could we take out of a GCF? What could we take it out of the first one? A 2x. When we take a 2x out of 2x squared, what are we left with? X and then plus 2. Now we ask the same question. We have a plus sign here. What can I take out of 1x plus 2? Trick question. A 1. You really can't take out anything but a 1, right? And what's left behind it? X plus 2. Now your teacher would always say, make sure, you guys, that you have the same thing in the brackets. But why? Why did you have to have the same thing in the brackets? Those 2 blue things are just terms, right? I underlined the 2 separate things. Those are terms. Terms are connected by plus sign. We agree? So this is one term, this is another term. Just like up here, in this bracket up here, you told me I could take out a 2x. We agree from these 2 terms? What can I take from these 2 terms? X plus 2. We agree? I can take an x plus 2 out of both of them. Then what's left over? 2x plus 1. So I have x minus 3, x plus 2, and 2x plus 1. So had you picked, Kyle, had you picked the -2, this here would factor to give you x minus 3 and 2x plus 1. That's the only thing that would happen. But we'd still get the 3. What's up? What's your question? Because both of you don't know the answer to it. Why are we doing what? You can ask that. What's your question? Why are we getting these? Why are we putting them together? No, carry on. Because we're finding factors. Because way back when, up here, it says factor. That's the reason why. I just skipped over that piece. You might not have seen that. But that's the reason why. Because it says factor the examples. So in order to factor in grade 11, when you had something like even just a difference of squares and you were told to factor it, right? It was x plus 3, x minus 3. And then you'd box these and put them together. And those were my two factors, right? That's all we're doing. It's just that we don't have a squared, we have a cubed. So I'm just getting all the factors and then boxing them. Does that make more sense as to what we're doing? It's because you didn't see this part up here. You're just seeing like C and some random polynomial laying there, and we're putting some in brackets. But that's because my fault. I didn't point that out. It says factor. Does that make more sense? So it says to find factor, so that's how we factor a degree 3. Because until now, we've only factored degree 2 quadratics. Okay? Does that make more sense? All right. Nope. Here's your homework.